Okay, well, welcome back to our class on software engineering. We've made a lot of progress here, and we're now done with these two major sections that we have covered so far, the introduction to software engineering and also the system dependability and security. Now we're moving on to this next section on advanced software engineering. And so the first thing that we'll talk about today will be software reuse. In terms of software reuse, the four areas that we'll address are the reuse landscape, talking about application frameworks, software product lines, and application system reuse. In general, in software reuse, most engineering disciplines, systems are designed by composing existing components that have been used in other systems. So you're not building from scratch. Software engineering has been more focused on original development, but it is now recognized that to achieve better software more quickly and at lower cost, that there needs to be a movement of design processes that is based on systematic software reuse. So it's been a major shift in maybe the last decade or so. And so here are some things that need to be thought about in terms of reuse-based software engineering. So for system reuse, this is a complete system which may include several application programs that are combined to be used. You can have application reuse, where an application may be reused either by incorporating it without changes or into another, or by developing application families. You can have component reuses, where components of an application from subsystem to single objects may be used. And finally, you can have object and function reuse. This would be where small scale software components that implement a single well-defined object or function are reused. So what are the benefits of reuse? You can have accelerated development, you can have an effective use of specialists, and you can have increased dependability. Things that have already been used, if it's integrated properly, it can actually be saving you a fair amount of time as a result. You can have lower development cost, you can have reduced process risk, and you have standard compliance. So those are all good benefits that need to be thought about. In terms of problems or use, there's the issues with creating, maintaining, and using a component library. And so are you able to refactor what you're going to be doing to fit into the ecosystem as you see it? There's finding, understanding, and adapting reusable components. Is it easy enough to find out how to be using these components? And then there can be increased maintenance costs. That you're likely not going to have the source codes available. And so if there's something goes wrong, you may be more dependent. You have to be intimately tied with an external vendor. There can be a lack of tool support. Software tools do not support development with reuse. That may be something you'll run into. And there could be this idea that, well, we didn't build it. And so there may be some pushback from the developers that you have in a particular company. So what is the reuse landscape? So in general, the reuse landscape, although reuse is often simply thought of as the reuse of system components, there are many different approaches to reuse that may be used. Reuse is possible at a range of levels, from simple function to complete application system. So the reuse landscape covers a range of possible reuse techniques. So here's just an illustration of the kind of things that can come into play for the reuse landscape. And so you can be having an application framework, product lines, application system integration, configurable application systems, and just this whole gambit of possible things, ranging from maybe just a design approach. So you're reusing design or architectural patterns. You're figuring out how to wrap legacy systems, and so you maintained a well-proven code, but you translate it into a more modern construct that you have with what you're doing, and that just the list goes on. So we have this in several charts that you can look at in more detail. So you have the application framework, application system integration, architectural patterns, aspect-oriented software development, and component-based software engineering. So those are the first set of things that you can be thinking about. You have configurable application systems, design patterns, ERP systems, legacy system wrapping, and model-driven engineering, which I think is something that's getting more traction. Plus, there's program generators, program libraries, service-oriented systems, software product lines, and system systems. All of those are things that can be talked about and leveraged in terms of approaches that support software reuse. So what are reuse planning factors? You have the development schedule for the software, the expected software lifetime, the background skills and experience of the development team, the criticality of the software and its non-functional requirements, the application domain, and the extension platform for the software. Okay, well, let's get into talking about the application framework. In terms of a definition, a framework could be defined as an integration set of software artifacts such as classes, objects, and components that collaborate to provide a reusable architecture for a family of related applications. So in terms of application frameworks, frameworks are moderately large entities that can be reused. They are somewhere between system and component reuse. Frameworks are a subsystem design made up of a collection of abstract and concrete classes and the interfaces between them. The subsystem is implemented by adding components to fill in parts of the design and by instantiating the abstract classes in the framework. For web application frameworks, these support the construction of a dynamic websites as a front end for a web applications. And so they are now available for all of the commonly used web programming languages, whether it be Java, Python, Ruby, etc. And interaction model is based on the model view controller composite pattern. And we talked about that a little bit earlier. And so the model view controller, the system infrastructure framework, you have a GUI design. This allows for multiple presentations of an object and separate interactions with these presentations. And the model view controller framework involves the instantiation of a number of patterns, as we talked about in chapter 7. So just as a reminder, the model view controller, and so you have all of the control methods and the various states. Then you have that goes into the view and the way that is viewed. And then finally you have the model, the methods and all that. And there's an engagement between each one of those areas. So what are some of the features that we might want to be thinking about? There's security. WAFs may include classes to help implement user authentication and access. For web dynamic pages, you have classes are provided to help you define web page templates and to populate these dynamically from the system database. You have database support. The framework may provide classes that provide an abstract interface to different databases. You have session management, where classes are there to create and maintain sessions. It can be a number of interactions with the system by user and are usually part of a WAF. And finally, most user interactions, most web frameworks now provide AJAX support, which allows for interactive web pages to be created. For extending frameworks, frameworks are generic and are extended to create a more specific application or subsystem. They provide a skeleton architecture for the system. And so there's a possibility for extending the framework, and this involves adding concrete classes that inherit operations from abstract classes in the framework and adding methods that are called in response to events that are recognized by the framework. Problem with frameworks is their complexity, which means that it takes a long time to use them effectively. So here is a picture of inversion of control in a framework. And so just to give you a perspective, you can see that diagram. So what are the type of framework classes? And so there's the system infrastructure frameworks, and that supports the development of system infrastructure such as communication, user interfaces, and compilers. There's middleware integration frameworks, standards and classes that support component communication and information exchange. And there is enterprise application frameworks that support the development of specific types of applications such as telecommunications or financial systems. All right, well, let's talk about software product lines. Software product lines or application families are applications with generic functionality that can be adapted and configured for use in a specific context. A software product line is a set of applications with a common architecture and shared components, with each application specialized to reflect different requirements. And so adaptation may involve components and system configuration, adding new components to the system, selecting from a library of existing components, and modifying components to meet new requirements. And so here is a picture of base systems for a software product line. So you have your core components that must be there. You have configurable application components, and then you have specialized application components that are all related as such. For the base application, these are the core components that provide infrastructure support. These are not usually modified when developing a new instance of a product line. Configure components that may be modified and configured to specialize them to a new application. Sometimes it is possible to reconfigure these components without changing their code by using built-in components configuration language. Specialized domain-specific components, some or all of which may be replaced with a new instance or a product line is created. In terms of application framework and product lines, application frameworks rely on object-oriented features such as polymorphism to implement extensions. Product lines need not be object-oriented. For example, you could have embedded software for a mobile phone. Application frameworks focus on providing technical rather than domain-specific support. Product lines embed domain and platform information. Product lines often control applications for equipment. And finally, software product lines are made up of a family of applications usually owned by the same organization. For product line architecture, architectures must be structured in a way to separate different subsystems and to allow them to be modified. The architecture should also separate entities and their descriptions in the high level in the system access entities through descriptions rather than directly. So here's an illustration of the architecture of a resource allocation system. And so you have the user interface, and so that's the interaction. You have the input-output management, authentication, delivery, and query management. You have resource management with tracking, control, and resource allocation. And finally, database management, where there's a transaction management and the resource database. So I won't go into this in detail, but this is going into more specifics for the architecture of a vehicle dispatcher. And so each one of those things has some more specifics. For vehicle dispatching, this is a specialized resource management system where the aim is to allocate resources, i.e. vehicles, to handle instances. And so adaptations include user interface level. There are components for operator display and communications. At the input-output management level, there are components that handle authentication, reporting, and route planning. At the resource management level, there are components for vehicle location and dispatch and managing vehicle status and incident logging. And finally, at the database level, there's equipment, vehicle, and map databases. So what about product line specialization? There's the platform specialization, there's environmental specialization, functional specification, and process specification. For platform specification, there's different versions of the applications are developed for different platforms. For environment specializations. There's different versions of the applications to handle different operating environments, such as different communication equipment. And for functional specialization, there's different versions of the applications for customers with different requirements. And finally, process related, there's different versions of the applications to support different business processes. So here's an illustration of product instance development. You can elicit stakeholder requirements, choose the closest fit system, and then you can either renegotiate system or adapt existing system to deliver the new system instance that is closely aligned with what a customer would want. For product instance development, you can elicit stakeholder requirements. You can choose what is the closest fit member. You can renegotiate requirements as necessary, adapt existing systems, and deliver new family members, as we just showed in the figure. For product line configuration, you can have design time configuration, where the organization that is developing the software modifies a common product line core by developing, selecting, or adapting components to create a new system for a customer. Or you can have the deployment time configuration, where a generic system is designed for configuration by a customer or consultants working with the customer. Knowledge of the customer's specific requirements and the system's operating environment is embedded in configuration data that are used by the generic system. So here is an illustration of what the deployment time configuration can look like. So you have the configuration planning tool. It flows into the configuration database, and then you can be looking at either generic systems and see how they would work, and you engage with the system database. In terms of the levels of deployment time configuration, component selection, where you select the modules in the system that provides the required functionality. You have workflow and rule definition, where you define workflows, how information is processed stage by stage, and validation rules that should apply to information entered by users or generated by the system. And finally, you have parameter definition, where you specify the values of specific system parameters that reflect the instance of the application that you were creating. Okay, let's talk about application system reuse. An application system product is a software system that can be adapted for different customers without changing the source code of the system. The application system has generic features and so can be used or reused in different environments. Application system products are adapted by using built-in configuration mechanisms that allow the functionality of the system to be tailored to the specific customer needs. And so an example would be a hospital patient record system, where separate input forms and output records might be defined for different types of patients. So what are the benefits of application system reuse? As with other types of reuse, there's more rapid deployment of reliable systems can be a possibility. It's possible to see what functionality is provided by the application, and so it is easier to judge whether or not they are likely to be suitable. Some development risks are involved by using existing software. However, this approach has its own risk, as will be discussed. Businesses can focus on their core activities without having to devote a lot of resources to IT development, system development. And as operating platforms evolve, technology updates may be simplified, as these are the responsibility of the COTS product vendors rather than the customer. For the problems of application system reuse, requirements usually have to be adapted to reflect the functionality and mode of operation of the COTS product. The COTS product may be based on assumptions that are practically impossible to change, and choosing the right COTS system for an enterprise can be a difficult process, especially as many COTS products are not well documented. There may be a lack of local expertise to support system development, and the COTS product vendor control system support and evolution may not match what you have or want to have in your organization. For configurable application system, configurable application systems are generic application systems that may be designed to support a particular business type, business activity, or sometimes a complete business enterprise. For domain specific systems, such as systems to support a business function, like document management, you provide functionality that is likely to be required by a range of potential users. Okay, in terms of COTS solutions and COTS integration systems, you can have configurable application systems where you could have, and you could be thinking of the application system integration that would be associated. That's what we're trying to summarize with this chart. So a single product that provides the functionality required by the customer is based on a generic solution and standardized processes. Development focuses on a system configuration. The system vendor is responsible for maintenance, and the system vendor provides a platform for the system. And so you can see how there's a demarcation of the software provider, and you have to be thinking how to integrate that in. For enterprise resource planning, this can be a system that is a generic system that supports common business processes such as ordering and invoicing, manufacturing, etc. They're very widely used in large companies, and they represent probably the most common form of software reuse. The generic core is adapted by including modules and by incorporating knowledge of business processes and rules. And so here's an example of an architecture for an ERP system. You can look over that. And so there's a number of modules to support different businesses functions, a defined set of business processes associated with each module, which relate to the activities in that module, a common database that maintains information about all related business functions, and a set of business rules that apply to all data in the database. For ERP configuration, there's the selecting the requirement functionality from the system, establishing a data model, defining business rules, defining the expected interactions with external systems, designing the input forms and output reports, designing new business processes, and setting parameters that define how the system is deployed in its underlying platforms. And so these are the things that you would have to be dealing with in terms of configuration. For integrated application systems are applications that include two or more application systems, products, and or legacy application systems. You may use this approach when there is no single application system that meets all of your needs, or when you wish to integrate a new application system with systems that you already use. For design choices, which individual application systems offer the most appropriate functionality? Typically, there will be several application system products available, which can be combined in different ways. And then how will the data be exchanged? Different products normally use unique data structures and formats. You have to write adapters that convert from one representation to another. And finally, what features of a product will actually be used? Individual application systems may include more functionality than you need, and functionality may be duplicated across different products. So here's an illustration of an integrated procurement system. And so you have the client and the server. And so the client has a web browser and an email system to engage with it. And then in the server, you have the e-commerce, having an adapter, say if you have like an ordering and invoicing system, and you need to be communicating with an email system. And so here you have several adapters that are required to go from one product to another. For service-oriented interfaces, application systems integration can be simplified if a service-oriented approach is used. A service-oriented approach means allowing access to the application system's functionality through a standard service interface with a service for each discrete unit of functionality. Some applications may offer a service interface, but sometimes a service interface has to be implemented by the system integrator. You may have to program a wrapper that hides the application and provides externally visible services. And so here's an illustration of application wrapping. And so you have the application, and then you have how the service wrapper engages it with various services. So what are the issues with application system integration? And so there can be a lack of control over functionality and performance. The application systems may be less effective than they appear. There can be problems with application systems interoperability. Different application systems may make different assumptions. That means integration is difficult. There may be no control over system evolution. Application system vendors, not system users, control the evolution. And so it may be morphing in the direction that you might not want it. And then you have to be considering the support from system vendors. Application system vendors may not offer support over the lifetime of the product. Okay, just to finish up with a few key points. There are many different ways to reuse software. These range from reuse of classes and methods and libraries to reuse of the complete application systems. The advantages of software reuse are lower cost, faster software development, and lower risk. System dependability is increased. Specialists can be used more effectively by concentrating their expertise on the design of reusable components. Application frameworks are collections of concrete and abstract objects that are designed for reuse through specialization and the addition of new objects. They usually incorporate good design practices through design patterns. Software product lines are related applications that are developed from one or more base applications. A generic system is adapted and specialized to meet special requirements for functionality, target platform, or operational configuration. Application system reuse is concerned with the reuse of large-scale off-the-shelf systems. These provide a lot of functionality, and their reuse can radically reduce cost and development time. Systems may be developed by configuring a single generic application system or by integrating two or more application systems. Potential problems with application system reuse involve lack of control over functionality and performance, lack of control over system evolution, and the need for support from external vendors and difficulties in ensuring that the system can interoperate. Okay, that's a quick summary of the first part of our advanced software engineering section. So thank you very much.